Everybody's talking about RAG, everybody's talking about agents. You got to engineer the solution with the right components. Otherwise, out of the box systems cannot solve these kind of use cases. This is real data that we are getting from customers and real production use cases that we are solving. AI has been going on for the last many decades. So for the last 2 years, AI has really taken off with advent of generative AI. And one of the most prominent use cases is what is called RAG, or agents. RAG is a retrieval-augmented generation. You can leverage RAG and other related technology to answer questions, and that's what agent workflow is. In short, every customer has a ton of data. The data is the enterprise knowledge of any company, and that data, if you want to be able to talk to that data, get answers from that data, that's typically what RAG enables, right? So RAG is retrieval augmented generation, where you can retrieve an information from any of your data sources and generate a response to a question and present that answer to the user. So that helps you build generative AI apps on your first party data. And Google has an excellent product for that called the Agent Builder. And that allows you to get started with RAG quickly. An agent builder is as simple as you throw a bunch of documents at it and you can query and get answers to it. This is Agent Builder. What I've done is I've preloaded it with a bunch of quarterly earning reports for Fortune 50 companies, and now I can ask questions off of that data. So for example, I'm asking here, what is Google's revenue for this quarter, and how has that changed for the same quarter last year? So what's the year-over-year growth for Google? So it says Google's revenue for fourth quarter 2023, which was the last report that I had uploaded for Google, is $86 billion. It's a 13% increase for the same quarter last year. And strong performance was driven by growth across all segments. So it gives you a bunch of information, and you know that it's not hallucinating. You know that it's not making it up. You know it does not depend on LLM's memory, because it is able to give you a source citation. If you click on this number 4 here, it takes you to a document which shows you where the data is coming from. So it is coming from this quarterly earning report. You can see that the consolidated revenues were $86 billion, up 13% year over year. It was able to extract the information from here and was able to give you the answer. So that is RAG. Helps you get Agent Builder helps you get started with RAG very quickly. If the information is buried in thousands of documents, right, or millions of documents in some cases with our clients, you don't have to have an individual who is indexing everything and manually searching for stuff or doing keyword searches and then looking at thousands to get the answer. Now you can have AI read all of them, essentially index all of them, and then ask questions off of AI. And that's what Agent Builder allows. This is the place where a lot of the customers get very excited because they see early validation. But this is the place where things also start to fall apart, because now they get to real data, and then real customer data is messy. It comes in a lot of different variations, a lot of different modalities. And as the customer tries to scale the solution, it kind of tries to fall apart, because the plain vanilla Agent Builder RAG solution is great to get started, to get early validation, but it's not fully there yet to do all things production. And I'll explain what the corner scenarios are and how you can solve that with Google Cloud. So Google Cloud does have all the tooling required to solve it, but let's look at what are the problems, right? So the main problem is the real data is messy. Documents are not always plain text. Sometimes they're text, and then there are embedded tables, embedded data in form of graphs and charts and infographics. Sometimes there is structured data that they want to augment. Okay, I've got a ton of documents, but then I've got my data warehouse, which has my customer data. I've got my CRM, which has more information. Can you integrate all of that and ask a question? Can I ask a question across all of that? Because I want to reference this information there, that information there. There are also videos and audios and image files. Sometimes there are call recordings, sometimes there's scanned documents, and you want to be able to ask questions across all of them because you don't know where the information is. And that is where, a lot of the clients' real data is, and that is where, when they start to do it, it kind of tries to fall apart. And so the question now is, how do we do this? How do we solve it on real clients' data? How do we take this RAG solution, which we were able to get an early validation very quickly using Agent Builder? How do we take it to production so that the client gets real value out of it? And to do that, this is the architecture on Google Cloud. So remember, the Agent Builder architecture was simple. It was just one step. You throw in the documents and that's it. It's easy for you to do the POC, proof of concept, and you can get early validation. But when you have to take it to production, that also is available on GCP, but that's a different tooling. This is the tooling, what it looks like. So the documents are there and the content is there. You need to ingest it. The content is ever evolving. So you need to set up ingestion pipelines That way we can continuously keep the system updated of whatever changes are happening in the content. So ingestion pipeline is critical. As the content comes in, you got to be able to parse the content, classify the content. Sometimes you have to split the contents, annotate the contents, whether something is an infographic or a table or a text or whatever. Then you have to chunk it, generate embedding, build a vector index, create ranking, and then you have to generate the answers. Sometimes you have to enrich the answers using a knowledge layer that you have to build on structured data, semi-structured data, and so on and so forth. And to run all of this in production successfully and to scale it to millions of users, which is usually what the case is in production, you have to make sure you have the infrastructure that can support the production volume. So you need Cloud Run, Cloud SQL, Composer, depending on how you want to orchestrate it. You need monitoring and logging. You need the build process, deploy process, and so on. And then you also need security, networking, and whatnot. Again, Google provides a whole gamut of tools to manage production environments, and this is what it looks like. So this is an example implementation of that. So this has the same data set that I was talking about, where it has some 50 odd quarterly earning reports, and I can ask question. And the first question that I'm asking is the same question: what's Google revenue? And gives me the similar answer. Again, remember, this is something that Agent Builder can do. So this is not exciting. But let me tell you some other questions that clients kept on asking us, because of which we had to build a knowledge layer with the LLMs, and we have to build a more complex tooling around it to solve those kind of questions. So, for example, if somebody asks, what are the top 5 companies that have had highest year-over-year revenue growth? Right, a very valid question. A lot of customers ask stuff like that. If your customer is in the legal domain, they might ask, okay, which customers have more than 10% discount in the SOW? The theme here is, in many cases, you have to understand, you need to have an aggregated understanding of all the knowledge that you have in your knowledge base, not ask a question from a specific document. And that is something that RAG cannot do. It's not that Agent Builder cannot do. RAG itself, RAG as a concept cannot do it, because if you understand, RAG is Retrieval-Augmented Generation. So you need to retrieve the information from a particular document, process it, and then give an answer. This information, what are the top 5 companies that have the highest revenue growth? This information is not there in any one quarterly earning report. And if it is not, then I cannot retrieve this information from 1 to 5 or 10 documents, whatever is my top K, and I cannot answer based on that, right? So what I need to do is I need to have an aggregated understanding of everything, and then I have to answer that. And for that, that architecture becomes important, because you need to build a knowledge, you need to build an information layer that can answer it. So now we are able to answer this question based on that architecture. I'll take another example. Which companies do not have positive revenue growth? Again, this is something, what is unique here? You're asking a negative question. Which companies do not have something? Again, RAG is designed to search for something and get an answer based on what you search, what the results are, right? It's based on semantic search and then getting an answer using generative AI. That is also not possible with GenAI, because imagine this. If I ask you, do not think about an elephant, the first thing that you think about is what an elephant looks like. You think about an elephant immediately. That is what RAG does. As soon as you say which companies do not have X, or tell me a scenario where X is not there, you will want to do semantic search on that question. You will get the chunks where the answer exists, and then you would want to ask there. So in most cases, you will get hallucinations. So that's not a good scenario to do in case of RAG as well. So these are some examples. Let me give you another example. This is again data from a real client. What they're doing is they're a financial services company, and they want to create financial instruments on top of airline stocks. And they gave us a bunch of ESG reports from those airlines, and they wanted to be able to do some research on top of it. And those reports are fairly complex. I'll show you an example. So here, the question that the research analyst is asking is, what is the gender distribution for American Airlines by employee category? So gender distribution by employee category for American Airlines. So the system goes back, looks at the document, and says gender distribution for American Airlines employees by category is director and above, 30% female, 70% male, and management and professional, and so on and so forth. So it gives me all the categories and gives me the male-female ratio. So remember this: director and above, 30% female, 70% male. Now, where do you get this answer? So it's important for us to build trust so that we can say that this is the right answer or not. So we do grounding. If you go into the source, it says the information came from here. So American Airlines report, page number 60 is where the most probability is that it got the answer. So if I go here, if I pull up page number 60, you will see that, the answer came from here, director and above, 480, 30, 70. Now, what is 30? 30% is female, 70% is male. So you will see that this is a fairly complex page to read, because not pure text. There are tables, and then tables have headers and subheaders with different colors, and you have to be able to understand that you're talking about employee category. And it doesn't really say, yeah, it says gender diversity here on the top. So this is gender distribution by employee category, and this column is female, this column is male, it says at the header. So this is another very common scenario that you will have to solve with your customers as you start to ingest more and more document. You realize that documents themselves have complex structures. They have tables and all sorts of tables that we are seeing. Sometimes there is headers, no headers, and whatnot. So you can't really do anything hard coded. You can't really define rules for it. It all has to be AI driven, and that's one of the things that we have to do, is being able to process tables. I'll give you just one more example. So here we say, what's the gender distribution by employee category? Same question, but for Ryanair, another airline that they wanted to do the same research on. So here also we say this is the gender distribution: PLC board 36% female, 64% male, and so on and so forth. Here the source is this file. Page number 19 is where it says it got the answer. So if I go to page number 19 of this report, you will see that the answer is coming from this graph. Now, this is a fairly complex, this is a very, very complex graph for any out-of-the-box system to solve, because you see it says, okay, PLC board, management, flight crew, it gives you all the categories here. It says gender diversity, so you know it's gender distribution is talking about that. And then it says 36% yellow background, 64% blue background. Now, yellow background is female, blue background is male. So for a text-based system to understand all of that is extremely difficult, but because Gemini is multimodal, Gemini is able to do it. But then again, you got to engineer the solution with the right components. Otherwise, out-of-the-box systems cannot solve these kind of use cases. And this is real data that we are getting from customers and real production use cases that we are solving. These are some of the complex use cases. I listed some of them here for our deck today. So data aggregation, we talked about when you need aggregated knowledge of all your data. Negative questions, when you're trying to ask something in a negative term, like tell me some, which customers did not renew their contract last year. So if you have all the documents about renewals, you don't know which customers did not review. So all the negative, how do you answer that? We talked about multimodality, where the information is not only in text, but there are infographics and images and tables and all of that. How do you answer that? There are other use cases, for example, geospatial data. So customers are asking us this as well, like the real world is geographically distributed. So somebody says, what are my top 10 clients within 100-mile radius of my headquarters? Now, best of luck calculating 100-mile radius using just RAG, but GCP Tech can do it, because BigQuery can do geospatial data. Google has Google Maps API, so you can code in a very intelligent solution to answer geospatial questions. But again, out of the box, RAG itself cannot do it. But so you got to design your agents which are much smarter than RAG. Also, complex structures. Sometimes there are answers that need to be answered by retrieving information from multiple documents, which by themselves don't make sense because the chunks are disconnected, but they have to be queried together. So I'll give you an example. So imagine this is with an agent built on thousands of contracts for, let's say, a law firm, right? So if somebody says, which client with contracts of less than $1 million mandate background checks, right? Now imagine there is a 50-page document, which is a CMA. On the first page of the document is the name of the client. On page number 37 is their requirement for background checks. And then there is another document, which is a statement of work, which has the name of the client and the reference of the CMA on page number 1, and page number 42 has the dollar amount, right? Now, all these 4 chunks may be retrieved when you're doing the semantic search to implement RAG, but they're all disconnected. Apart from these 4, there might be 100 other chunks which are retrieved, because a lot of them talk about $1 million in revenue. A lot of them talks about background check, but you don't know which chunk is related to which client and which document, because they don't have relationships between them when you do pure RAG, right? So you need to be able to understand and build those relationships and complex structures of documents and their hierarchies in some cases. There are other things like ambiguous queries. So you need to do multi-turn conversation. So if I ask how many clients are there in New York, well, do you mean New York City and New York State? Typically, a RAG implementation will not ask that clarifying question, but you can design your system to ask clarifying questions if something is not clear. There are so many of these use cases where a lot of these scenarios require you to go beyond just an out-of-the-box solution and look at the full production architecture and look at the skill set required to implement that. There are 100 ways to architect this thing, right? So what I showed you, this architecture is a candidate architecture. Okay, you have, so the point here is you have to be able to parse and annotate a document. You need to understand the layout where the text is, images, and so on, so that you can process it accordingly. An image processing pipeline may have some extra steps than just a pure text processing pipeline. Tables, you might sometimes you might have to process differently, and you have to handle differently while querying also, while retrieval and generation. So Doc.AI is a candidate solution. If you want to use another component in place of document AI, if you want to use Gemini, if you want to use LLM, some other LLM, we can do that. It's not document. This is not hard coded that this is what the architecture is. The point to show here is that just a plain out of the box system is great for POC. For production, you need to put a more comprehensive tooling, and you need to work with somebody who has experience across all that tooling.